All right, so question number 5, which is the first one that we didn't go over in class, is going to be a police car is parked 0.3 miles to the side of the road. A car passes by the police officer. He uses a radar gun to measure the car's speed. When the car is exactly 0.05 miles from the police officer along the diagonal, the gun measures the car's speed is 75 miles an hour. What is the true speed of the car along the road? So we can think about the problem as a triangle. The cop is here. The edge of the road is right here, and the car that the cop is looking at is over here. So the police car is parked 0.3 miles to the side of the road, so we know that, right? So we have A, we have DA/DT, we have B, and we have DB/DT, and we have C and DC/DT, all right? Because this is a related rates problem that breaks down into a triangle, so we're going to be able to break it down like this, and then we're going to use the Pythagorean theorem to figure shit out, okay? So police car is parked 0.3 miles to the side of the road, so we know our B is 0.03. And we know that this is going to be 0 miles per hour because the police car is not moving. The road is definitely not moving. So the distance between the two is not going to change. If the distance isn't changing, the rate of change, if something isn't changing, right, the rate of change is 0. So the rate of change of that is going to be 0. All right, so then when the car is exactly 0.05 miles from the police car, the distance between the police car and the car is the hypotenuse, right? So 0.05 miles, that's going to be our C. And it says the gun measures the car's speed as 75 miles an hour. So our DC/DT is going to be 75. So then we need to figure out our A and our DA/DT, right? Because that's going to be important for the problem. So A squared plus B squared equals C squared. So we know our C is 0.05. We know our B is 0.03. And we know or actually we don't know our A squared yet, but we're going to figure that out. So it's going to be A squared plus 0.009 equals 0.025. So then we're going to subtract 0.09 to get that A squared by itself. So then we're going to get 0.016 is equal to A squared. So we're going to take the square root of both sides, and we're going to end up with 0.04, right? Because it's kind of like the square root of 16 if you think about it, which is 4. So then we're going to go up here, fill in 0.04, and DA/DT is what we're looking for, right? So, because we want to know what is the true speed of the car along the road. So we got everything except DA/DT, but that's what we're trying to find. So we need to take the derivative of the Pythagorean theorem. So A squared plus B squared equals C squared. That's going to be 2A DA/DT plus 2B DB/DT equals 2C DC/DT, right? Because that's 3 power rule problems, simple, straightforward power rule problems. And then we have to throw in the derivative of the variable with respect to time for each of those terms. So that's going to be 2 times, we said A is 0.04. We said DA/DT plus 2. We said B is 0.03. We said DB/DT is 0 equals 2. We said C is 0.05. And we said DC/DT is 75. So then that's going to be 0.08 times DC/DT. Or sorry, times DA/DT plus 0, right? Because all this shit is nice and fancy, but when it's all multiplied by 0, it just ends up being 0. Equals 2 times 0.05 is going to be 0.1, and that's going to be times 75, and that's just going to give us 7.5. So then we're just going to divide, right, get rid of the 0. We're going to divide both sides by 0.08. DA/DT, 75, that is going to give us 93.75. I used a calculator for that, okay? And because on the quiz you won't be given something with this many decimals, you'll be given nice whole numbers to work with. I'll tell you that much. So this is going to be miles per hour. That is our DA/DT. So that's going to be our answer there because that is our A, right? Okay, so then The next one is going to be a rocket flies straight up at a constant speed of 10 feet per second. And an observer stands 30 feet from the launch pad. When the rocket is 40 feet high, how is the angle above the horizontal from the observer to the rocket changing? Well, let's figure that out. So, if we draw our triangle, the observer is here. The launch pad is here. And the rocket is here. So, we've got A, dA dt. B, dB dt. C, dC dt. And then now we've got theta down here. So we've got theta and d theta dt. But we'll get to those in a second. We got some work to do first. All right, so the rocket flies straight up at a constant speed of 10 feet per second. So, oh wait, sorry. So our dA dt is 10 feet per second. An observer stands 30 feet from the launch pad. So B is 30 feet. We also know that dB dt is 0 feet per second because the observer is not moving, right? The rocket is the one doing the moving here. The observer is standing still, and the launch pad is sure as shit staying still. So the distance between the observer and the launch pad isn't going to change at all. So the dB dt is going to be 0. And then we can use... Oh, when the rocket is 40 feet high. All right, so A is going to be 40 feet. And then we can use the Pythagorean theorem to figure out C. So 40 squared plus 30 squared equals C squared. So that's 160 plus, 1,600 plus, what was that, 900 equals C squared. So that's 2,500 equals C squared. So you take the square root of both sides, 50 equals C. So C equals 50. dC dt, you could figure that out. You can take the derivative of the Pythagorean theorem and figure it out if you want to. It's not going to be relevant to this problem, but we do need C. So we can leave that as a question mark for now. Again, you can figure it out, but we're not going to end up needing it. Because what we're going to need is, right, so we've got, here I'm going to move this up here so you can see it better. But we're, oh, God damn it. We're asked to find the rate of change of the angle, right? So this is asking us to find d theta dt. That is what we're going to be looking for here. So in order to get d theta dt into the problem, we need to use SOHCAHTOA. And we're going to need to take the derivative of SOHCAHTOA. So we're looking for, right, we know everything about A, which is compared to theta, opposite, right? So the O's here, right? We know everything about A, so we want something that gets opposite involved. We also want something that gets adjacent involved, which is our B side. So tangent gets both opposite and adjacent involved, and since we know everything about the opposite and the adjacent, that's the one we're interested in, right? So we're going to say tan theta equals opposite over adjacent, which in this problem is A over B. So tangent of theta equals A over B. Now, we're looking for d theta dt. So you might just, fuck it, plug in 40 here, 30 here, call it a day. But that's not going to get you d theta dt, right, which is what you're looking for. If you want to get d theta dt, you got to take the derivative here, right, because the derivative of tan theta is secant squared theta times d theta dt. And then this A over B is going to be a quotient rule problem where your U is A and your V is B. So you got dA dt for the derivative here and then dB dt for the derivative of B. So then you're going to do U prime V minus UV prime over V squared, which is going to be dA dt times B minus dB dt times A all over V squared, which is B squared. So this is your derivative over here. Oh God, that's what a mess. Okay, here, what if we move this down? Okay, perfect. So this is what we're dealing with now. So let's fill in the stuff we know. We said dA dt is 10 and A is 40. So dA dt is 10 and A is 40. And we said B is 30. And, dB dt is 0. So now we're dealing with 300 divided by 900, which is 1/3. Okay, this is looking a lot more real. All right, so secant squared theta d theta dt equals 1/3. So then we can go back and we say secant is 1 over cosine, right? And we use SOHCAHTOA to say that cosine is adjacent over hypotenuse. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And so in this problem, our hypotenuse is 50 and our adjacent is 30. So this will be 50 divided, so secant theta equals 50 divided by 30. So secant squared is going to be 50 divided by 30 squared times d theta dt equals 1/3. So then you square the tops. That's going to be 2500 divided by 900 times d theta dt equals 1/3. Multiply both sides by 900. 2500 times d theta dt equals 900 over 3, which is just 300. And then divide both sides by 2500, and you got d theta dt equals 300 divided by 2500, which does not, here, let's just cross out all the zeros. So d theta dt equals 3 over 25, which cannot be simplified, and make sure you include the units. For whatchamacall, theta, it's always going to be radians per sec. Wait, is it second? Yeah, second. Yeah, what's our unit of time? Yeah, second, because it's feet per second. Yep. All right, so our answer here is going to be 3/25 radians per second.